All right, so here we go. We're going to do a quick recap, and then if you have review questions, we can do that, or we'll move straight into the law of cosine, which happens to be one of my favorite things. So, here we go. I'm going to put 3 triangles up here on the board. And your job is to tell me how many triangles are possible. So you're not necessarily solving the whole thing to find everything, but you do have to do some solving. So,
are we in a question? What problem are we on?
We're not
Oh.
No, I gave you the packet just because now you have it, and we'll have it when we need it. Right now, we are just taking a few more notes, doing 3 more practice problems to make sure everybody has this under control. Okay, so these are all law of sines problems. How do I know? Look here. See that pair of information, side and angle? When you have angle and side, a pair, you know it's going to be the law of sines. Tomorrow or next day, we'll look at problems that don't have that, and then we'll have to use the law of cosines.
Oh, so we are going to do cosine.
If we don't have any questions. If we have questions over tomorrow's test, we'll take care of those after we do these 3 problems. So, Jack, you're writing them down? Okay. And then we're going to need our calculators, because you know you have to do a little calculating. No, this is 3 separate problems. These are 3 separate problems, but the directions are how many triangles are possible. So in this situation, how many triangles are possible? How many triangles are possible here? How many here? Okay?
Well, we have to solve the whole thing.
I said you do not have to solve the whole thing. You do have to solve a little bit of it, though, because you got to find those angles before you can answer the question. But you don't have to find everything about all the triangles, no. lumber curve.
Do you not have to do anything with the second triangle?
We have to see if it's possible.
Well, yeah, but once it's possible, if it is possible.
After you solve it, ask them just how many solutions are there. So you're figuring out if it works or not. Either it does or doesn't. You don't have to solve it.
I got one.
As if it's greater.
Well, let's look at the first one. You should have the first one done by now. Did you get angle, see, when you set up your lost signs just straight away, did you get 22.07? So then you immediately said, okay, that's great. If there's a second answer, that angle would be 157. And then you stood back and said, wait a second, that's a 157 and that's a 26. I think that's too much, isn't it? So that one doesn't work. So we have just one possible triangle for the first set of data. Everybody understand that? What about that are we not clear on?
How come there can be multiple triangles?
Because it's an angle side-side situation. And that configuration of information is not a congruence postulate. If I gave you angle side angle, that's a congruence postulate, which means all those triangles are going to be the same. There's going to be one. But I gave you angle side side, which is not a congruence postulate. Okay. When I did number 2 for for setting up the lost signs, I got 35.69 for my angle. Right?
Right.
Which means that if there is a second angle, it would be 144.31. 180 minus the first. So I stand back and say, well, can I have a 30 and a 144? I can. It would make that angle really, really tiny, but it's possible. So this setup has 2 possible triangles. We set up our lost signs, we find the first angle. Then we check the second angle, which is always 180 minus the first one. It's either going to work or it's not. Now when I set this one up, everything went to heck and I got no solution. I got an error message. Did you? Which means this is an example of just bad information. There cannot be a triangle formed with that information. Okay? And since I didn't get a first angle, there's no way I'm going to get a second angle, so I just say 0 and move on. Got it? So if sometime when I see you soon, I throw a problem at you like this and say, how many triangles are possible? Everybody knows exactly what to do. Is having a calculator with you important in these coming days?
Yes.
It's absolutely essential. Absolutely essential. Okay? So make sure you have one. All right. So that takes care of 5-6. So, tomorrow night, you want to get started on 5-6? Or 5-5, we need 5-5. Start at 5-5, then you need to do it, because we are done. Did you find as you're doing review work, or can you think of something that we still need to review for tomorrow's test. Oh my, this is not good. Have we not done any reviewing yet? Why would we review ahead of time when we can do it all tonight, right? Yeah.
We don't have it till Thursday. No, we have it tomorrow. Honestly, Miss Ford.
We have it tomorrow.
Last period of the day.
Your test
Yeah.
is tomorrow.
I'm ready. Miss Ford, can we just do like the whole thing?
No, we don't have time to do the whole thing. I need to do the ones we have a question about. I mean, we did one whole thing. I don't know which one it was, but we did one whole thing.
Yeah.
We don't have time to do another thing.
You do
Anything off any of the other things.
you do number one.
Cassie actually has her hand up. Person.
No, they'll say the same thing though. The, pretest number 2, the number 1.
Pretest number 2. Number 1 is just a little arithmetic problem. We are simplifying. There are no signs or cosines or anything in it. You have simplified plenty with sines and cosines in it. This is exactly the same idea. The issue here is we got a little fraction in the middle of a big fraction. So I want to get rid of that. So I'm going to multiply every single thing in the whole problem by x. So on the top then, if I do that, nothing's canceling on the top. So I would be left with 2x squared plus yx. And on the bottom, I am canceling, that's why I did it. So I have 1 plus xy squared. Now, at this point, you're done basically. A lot of times when we do this, we can go ahead and factor the numerator. And you can factor the numerator. We can take an x out, right? But it won't do us any good. Because what's the whole purpose of factoring? To cancel. And if you're not going to be able to cancel, you can factor. It isn't wrong to factor, but I'm not going to because I can tell I'm not going to be able to cancel. So that's the final answer. That's all there is to it. I know. No need to be psyched out about that. All right. What else? On this sheet or another sheet? Whatever. It doesn't matter to me. Or if there's just a kind of problem you're thinking of, I can find one of those.
Same pretest number 2D.
2D is a verify.
That's number 1 and number 2.
This is pretest number 2. And we are verifying or proving this.
Which number is this? D.
Pretest number 2. D. 2D. Pretest number 2 on 2D. Alright, so what's your idea? What's your thought on this? Turn tangent into sine over cosine. Now we have 2 fractions that need to be added together. Girls, this is not a beauty salon. What is going on back there?
My hands being dry it kind of affects me with my Precal abilities. And taking notes, which is very important. I'm sorry.
We're going to add these together. We have 2 fractions. We're going to add them together. So we're going to get a common denominator, which means this one has to have a 1 plus sign, and this one needs a cosine. My common denominator then is 1 plus sine times cosine. So both pieces of the denominator are now my common denominator. So what do I have on top? Well, I can distribute here.
You got sine.
So I have sine
Plus sine squared.
plus sine squared
cosine squared.
Oh my goodness. Look at this.
And that equals 1.
That equals 1. So now I have sine plus 1 over 1 plus sine times cosine. We can cancel.
And the reciprocal.
So we're left with 1 over cosine, which is secant. So that's one of those examples of a problem that we did nothing tricky. Nothing. Step 1, change the tangent into sine and cosine. Step 2, get a common denominator. Step 3, if you don't know that identity, you are hopeless. Cancel, and you're left with it. Okay, that wasn't too bad.
You said we did a cheat sheet on
I'm going to give you a formula sheet that's just like your green one, only it's pink. Annie?
Can we do 3B?
3B, same paper, 3B. Now this is different directions. This kind you are solving. So your job, you said B?
Yeah.
So your job is to ultimately end up with something like x equals 60 degrees or something like that. That's when you stop.
So what about you subtract that sine x over?
We can subtract that sine x over. It's always a good idea to have your equation equal to 0.
And then you need to change one, right? So
Yeah, the one we can change is the 2x.
that's
We
the double.
can't do the problem, kids, with a 2x and an x, okay? We can't do it. So we need to change the cosine 2x. This is the one of the two on the sheet that have more than one, things that you can change it into. What are my options for cosine 2x?
You're gonna want to use that 1 minus 2 sine squared.
You're gonna want to use the 1 minus 2 sine squared because you already have a sine. Why in the world, if you have a choice, why in the world would you put cosines into your problem? Right? Doesn't even make sense. Now, I think I'm gonna divide out a negative and do some rearranging here. So I divided out a negative. I divided everything by -1 and rearranged so that I can see clearly I have a quadratic equation. And it'll factor. Double check my factoring. Just boil it back and see what happens. Did it work? Alright, so that means sine x equals 1/2 or sine x equals -1. Now with normal arithmetic problems, we're done. This is where we stop. But remember, when it's solved, your job is to go all the way to x equals. You need an angle. So, that first one says, the angle we're looking for has a sine of 1/2.
So first and second quadrant.
So it'll be in the first and second quadrants. That's exactly what you should think first. Where am I going to find this angle? It's either going to be in quadrant 1 or 2 because sine is y and that's where y is positive. Now if the sine is 1/2, then the angle, the reference angle, must be 30. So the two angles that have a sine of 1/2 are 30 and 150. Now, is it possible to have an angle that looks like that? That would be the sine is -1.
No.
Is that possible?
No.
No. So if the triangle's not possible, then where do I look to get the answer to that question? It's quadrangle. So I look at around my circle, and I'm looking for any place that has a sine value of -1. So where would a sine value of -1? Right here, which is which angle? 270. So there are the answers to the problem. You gotta go all the way down to x equals the angles. When it says solve, your answer is angles. What? No, not review work. The whole purpose of review work is to review, right? All right, anybody think of anything else? What?
We can do 5D.
5D.
Did we just do that?
5D. No, we didn't do 5D. 5D is, this is just formula recognition. Or identity, I should say, identity recognition. So when you see a square root, Maggie, the only identities that have square roots in them are the half angles. So you know this is one of the half angle identities. So this is going to be the sine of half an angle, because the half angle formula is the square root of 1 minus cosine over 2. So the angle is 50. So this is a formula for the sine of 25. So when it says simplify, it does not mean type in your calculator and write down some decimal. That's not what it means. We practiced enough of these, you know what you're supposed to do. Figure out which formula you're looking at. Four. This is another identity, so it's another prove. Change one side into the other. This is not going to be an answer like this. This is going to be make this look like that. So when we see the sine of something minus something, the sine of u minus v, what do we think of? Sine of the first, cosine of the second, minus cosine of the first, sine of the second. Right? Now, in some of the problems we do, like the ones that have 45s and 30s and stuff, we have to go through and find all 4 of these numbers.
But you don't.
Well, I can't. I don't know anything about x. They didn't give me any information about x. So that's just saying sine x, and that's just saying cosine x. But what about 180?
Well, one of them is going to be 0.
Well, one of them's going to be 0. I need to figure out which one it is. 180 is right over here. What's the cosine of 180?
0.
No, the cosine is x, -1. That's not on your formula sheet. You need to know cosine is x, sine is y. Sine of 180 is 0. So then this is a multiply. These things are being multiplied. So this is negative sine, and that's 0. So sure enough, that's what I was trying to end up with. You guys that need to go, probably better go. I mean, it's pretty bad when you go to the dentist and stay in 3-5, but oh well. Yeah, I couldn't care less if you were younger or whatever. All right, who else can think of any kind of problem that we need to review? Which one?
6B.
6B. Find the value of the cosine of 2A if the tangent is 3/4 and we are in quadrant 3. Well, there are two things that have to happen before I can get started. One is I gotta know what I'm dealing with, so I have to draw a picture of it. What am I dealing with? Where's my angle? What's it look like? The other thing that I take care of is, what formula am I gonna use? Because to evaluate the cosine of 2a or the sine of 2a or the tangent of a over 2, it doesn't make any difference. To evaluate any of those, I need a formula.
I'll just do.
So, this is the one that has 3. It doesn't matter, there's no advantage to any of them, so I'm just gonna use the main one this time, cosine squared minus sine squared. If you wanna use 2 cosine squared minus 1, or 1 minus 2 sine squared, that's great. Doesn't make any difference, we're all gonna get the same answer. Now I'm gonna draw a picture of my angle in quadrant 3 that has a tangent of 3/4. Now you need to be careful.
They're negative.
They're both negative.
And that's gonna be.
You don't see a negative in the problem because when you put opposite over adjacent, they cancel the negatives out. But they're both negative, and the hypotenuse is 5 by the Pythagorean theorem. Okay? So now I'm just gonna plug stuff in. So what's my cosine?
Negative 4/5.
Negative 4/5. I'm going to square that though, so it becomes 16/25. What's my sine? Negative 3/5. But I'm going to square it so it becomes 9/25. The formula says I take the cosine squared minus the sine squared, so I get 7/25 as the answer to the problem. Easy. Alright, what else can you think of that we need to make sure we know how to do for tomorrow?
I was gonna ask just to do 6A.
6a.
Just forget the other one.
6a is find the exact value of the sine of 105. Well, what do we know about 105?
60.
It's one of the things it is 60 plus 45. Is it other things? Oh, heavens, yes. But it is certainly 60 plus 45. So here we go. Formula says sine 60 cosine 45 plus cosine 60 sine 45. Because this is the sine of u plus v. The way we chose to break it down, it's the sine of u plus v. Alright, so I got 4 numbers I have to fill in here. We know the 45s are root 2 over 2. The 60s, some of you I'm sure have memorized. I have to always draw them because I don't want to get them mixed up.
So 1/2.
So the sine of 60 is 3 over 2. And the cosine of 60 is 1/2. So this is a multiplication, so I have root 6 plus root 2 all over 4. Nothing adds, nothing cancels. The answer is root 6 plus root 2 over 4, period.
You can do 5B.
5b is cosine squared minus sine squared. That's an identity. Which identity is it? Forget the angles for a minute and just figure out which identity is cosine squared minus sine squared.
Is that the cosine squared?
No, cosine.
It's cosine double angle,
Look, isn't that also the same?
and the angle is 77, so this is the formula for the cosine of 154.
Yeah.
No, 77 squared is
That's
No,
not the same.
no, I know that. I was
Be
gonna say
careful,
something
if
else.
this were a plus,
You had to.
then what would it be? 1. Cosine squared plus sine squared is 1. But it's not a plus, it is a minus, which means it's the double angle cosine identity.
That's on the green sheet, isn't it?
Yep, the double angle identities are on there, yep.
If it's a plus, it's 1, because that's cosine.
Cosine squared plus sine squared is 1, absolutely.
I was just thinking of the cosine. That's cosine minus sine, it's the same as the,
Oh!
that's why I
Oh,
was trying to
no,
say.
Brenton, you're exactly right. That would be cosine 77, cosine 77, minus sine 77, sine 77.
Yes.
What's that a formula for? The cosine of angle plus angle?
Yes,
What are your angles?
77.
77 and 77, what do you get when you add them together? Yeah. So, yeah, we can actually break it down into that if you want to. Yep.
But it's the double too.
Huh?
It's double as well. So
Yeah.
it's either way.
Yeah, some of the same thing twice is like doubling it. Yes, you're exactly right. In fact, that's where this formula came from, is from doing this one and noticing that, oh, they're the same. Way to be thinking. All right, test tomorrow. Anything else? We're all good. You turn that off. Thank you. Yeah, you can do. Can do. Crap, I don't have my